Welcome children. Today we are going to work on few problems based on this lesson, force and laws of motion. To begin with, let me take the sum 9.5 page number 121. For that, a graph is mentioned children. A graph is got velocity time graph is mentioned. In this, the important thing to be noted is velocity is given in terms of centimeter per second, which is not the SI unit, but we shall take as it is what is given. Time is given in seconds. In this, if we consider the object moves with this velocity, therefore its initial velocity is this 20 centimeters per second. In a time of 10 seconds, time taken is equal to 10 seconds. The object comes to 0, therefore final velocity becomes 0, that I have written. I'll read out. The velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given in the figure. How much force does the table exert on the ball to bring it to rest? The ball comes to rest, therefore final velocity becomes 0. It moves with some velocity, that is u is equal to 20 centimeters per second. Mass is 20 grams. Time taken is 10 minutes. We are asked to calculate how much does the force exerted by the table for an object to come at rest. We need to find out two things in this: acceleration and the force. Therefore, we have all the necessary things to calculate acceleration. We shall calculate acceleration of the ball. Acceleration A is equal to V minus U by T. You will write down one below the other children. Substitution part, V becomes 0, final velocity becomes 0, minus U becomes 20 centimeters per second. See, remember this is 20 centimeters per second. I am keeping it as it is. At the end, I will convert into meter per second. Divided by time taken becomes 10 seconds. Therefore, this becomes minus 20 by 10, 10 get cancels, acceleration will become minus 2 centimeter per second square. Now, if I want to convert this into meter per second, 1 meter has got 100 centimeters, therefore, it has to be divided by 100. Therefore, acceleration will become minus 2 by 100. This becomes 2 zeros are there. After 2 digits, you have to keep the decimal points in it. Therefore, this becomes 2, 0 point minus comes so much of meter per second square. Now, this becomes easy for us to calculate the force required. We know that F is equal to mass into acceleration. This relation is given by Newton's second law of motion. This law gives the relation between force, mass and acceleration. Acceleration which is produced in a body is directly proportional to the force applied and inversely proportional to mass. Is equal to mass is given about 20 grams. Let me convert that into kg. 20 by 1000 into acceleration becomes 0.02. 10 gets cancelled, will be equal to 2 divided by 100. Again, 2 divided by 100 is nothing but 0.02 into this acceleration, children, you have to mention with this minus, remember. Therefore, minus 0.02. force will be equal to plus into becomes minus 2 2s are 4. After 4 digits we have to keep the decimal point. 1 2 3 4.0. So much of Newton. This much of force is required for the table to make this ball comes to rest. Looking at the graph itself, you can write down the given children. This is the initial velocity of the body. After 10 minutes of time, it comes to stop. Therefore, final velocity becomes 0 whose mass is given. This is how it has to be calculated. Children, in this sum 9.6 page number 124, we have another easy sum. Children, listen. A bullet of mass 20 gram is horizontally fired with a velocity of 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? Here the word recoil is the new term. Recoil velocity means the backward velocity. Backward velocity. See children, this sum can be solved using law of conservation of momentum. Law of conservation of momentum has been proved since 3 centuries ago. This law came into existence after a large number of experiments and observations. They have proved that theorem or that law of conservation of momentum. In that we have seen how to prove that. Based on that, I have written this sum. See children, before firing and after firing, these are the two cases I have taken. Bullet and the rifle are the pistol. After firing bullet, see, mass of the bullet and mass of the gun varies. See, it's 20 grams. This is 2 kg. This remains C. Before firing children, remember, the bullet also will be at rest. The pistol or the rifle or the gun, this also will be at rest before firing children. Therefore, initial velocity becomes 0. So, its momentum becomes 0. Its momentum becomes 0. Total momentum becomes 0. Total initial momentum becomes 0. So, we need to take down this and equate it to 0. Mass is given. The bullet it travels with this speed. What will be the recoil velocity of the gun? Now, this one will take like this. The total final momentum. Total final momentum. These things completely becomes equal to 0 children. Therefore, final momentum M1 V1 plus M2 V2 will be equal to this 0. Because total initial momentum is equal to 0. Therefore, total final momentum will also become 0. That's law of conservation of momentum. The total momentum of a system remains conserved, remains unchanged, provided no external force acts on it. So, substitution part. M1 is 20 gram, children, remember, 20 gram, let me convert into kg, and it moves with a velocity of 150 meter per second, plus mass of the rifle becomes 2 kg into V2 is equal to 0. This part. Now, 1 0 1 0 1 0 1 0. These two numbers are divisible by 2. 1 times 2, this is 5 times. Again these two, 1 5 are, this is 3 times. See how simple the calculation becomes. Now let me keep this as it is. 2 into V2 is equal to, transpose these 3, that side becomes minus 3 children because of transpose. Now V2 will be equal to, minus 3 by 2. 2 from here comes here by cross multiplication. Therefore, V2 will be equal to minus 1.5 meter per second. So, the negative sign says that recoil velocity. Okay, the backward movement of the rifle or the pistol, the recoil velocity of the pistol will be minus 1.5 meter per second. It's the easiest sum, children. You have to write it in this way. So, these things will help you to solve the sums very easily. Before firing, after firing. Write down the details such as the bullet and the gun, and after firing, bullet and the gun. So, the total initial momentum becomes 0 because at rest, before firing, the bullet as well as the gun will be at rest. Therefore, total initial momentum is equal to 0. Therefore, total final momentum is equal to 0. In such a way, simplification and the final answer. Children, look into this sum, children. It's another easy sum. Let's try now. A girl of mass 40 kg, I have mentioned, children, jumps with the horizontal velocity of 5 meters per second onto a stationary cart. The cart which is at rest. This is stationary cart. Therefore, its initial velocity is 0. Full stop. The mass of the cart is 3 kg. What is her velocity as the cart starts moving, assuming that there is no external unbalanced force working in the horizontal direction? See, children, a girl of mass of 40 kg moves with the velocity of 5 meters per second. There is a cart whose mass is 3 kg, it's at rest now. Therefore, initial velocity is equal to 0. We are going to solve this sum using law of conservation of momentum. Therefore, I have taken before jump, after jump. After the jump, it is very important to note down, children. Before jump, it's very casual things. After jump, what happens? The mass of the girl, 40 kg, no doubt. What will become the mass of the cart? The 40 kg mass of a child jumps onto the cart. Therefore, the mass of the cart will become this 40 plus 3. 40 kg child stands onto the cart. Then again the mass of the cart 3 kg. Therefore, in this case, after its jump, mass of the cart becomes 43 kg. This is an important point to be noted. Once the girl jumps onto the cart, the girl just stands on it. She remains at rest. Therefore, this is taken as 0. Whereas the cart moves with the velocity. This velocity we are going to calculate. So, using law of conservation of momentum, children, we know the formula. Total initial momentum m1u1 plus m2u2 is equal to total final momentum m1 v1 plus m2 v2. Formula part I have written, children. Substitution part. Kg meter per second, kg meter per second, everything is given, children. So we need not to worry about the change of systems. M1 is 40 kg moving with initial velocity of 5 plus 3 kg moving with the velocity of 0 is equal to M1 is 40 kg is stands rest children, mass becomes 43 kg, moves with this velocity. Therefore, the first part becomes 200 plus 0 is equal to 0 plus 43 v2. This is nothing but 200 is equal to 43 v2. We need to calculate this children. Now 43 v2 is equal to 200. 43 v2 is equal to 200. Therefore, v2 will be equal to 200 by 43. Slowly you can divide and you can find out the value of this children. So much of meter per second. This is how the easy calculation part can be done. Before jump, after jump. The mass of the girl, mass of the cart. Here the mass of the girl remains same, but the mass of the cart becomes mass of the girl plus mass of the cart. She jumps onto the cart. Therefore, here this becomes 43. We need to find out with which velocity this cart travels. Right down. Consider this sum children. I read out 9.8. Two hockey players of opposite teams, while trying to hit a hockey ball on the ground, collide and immediately become entangled. This means two entangled becomes twisting together becomes one. One has mass 60 kg and was moving with some velocity 5 meter per second, while the other has mass 55 kg and he was moving faster with the velocity of 6 meter per second towards the first player. In which direction and which velocity will they move after they become entangled? See children, in this sum there are two things that we need to look into carefully. As per the law of conservation of momentum, we have written one becomes before collision, one becomes after collision. Two players, player A and B, mass m1 m2, mass m1 m2. The important change that we have to remember here is they play opposite to each other. Therefore, in this case, he moves from left to right. This person moves from right to left. Therefore, he moves opposite with the direction of A. Therefore, I have taken this negative sign. Arrow mark I have mentioned children. Mass and velocity. Mass with this velocity he moves towards this player, taking the hockey ball. The second part, they collide because they move opposite each other. They collide. Then entangled means they roll together, fall together. That becomes considered as one body, one mass. After entangled situation, their mass will become, after collision together, after entangled, the mass becomes m1 plus m2, 60 plus 55 becomes 115. With what velocity they fall and which direction they move. These are the two things we need to find out. Using law of conservation of momentum, we will solve this. Here, the total initial momentum, that is m1 u1 plus m2 u2 will be equal to, this total momentum is mass into velocity. Substitution part, m1 is 60 into 5 plus mass is 55 into its velocity is minus 6, which will be equal to, this is 115 5 into V. Simplification further, this becomes 300 children, plus into minus minus, this becomes 330. This will be equal to 115. Simplification of this, therefore it becomes 115 V will be equal to minus 30. V will be equal to minus 30 divided by 115. V will be equal to minus of so much value. We will be getting children. Slowly you can do this. Okay, find out the value. It becomes minus of some value indicating it, children. See here, the simplification and the substitution part is not important one, because once you know what is the situation, simplification and the substitution becomes easy. The given, writing the given is the most important part in this case. Two players, hockey players play A and B. A moves towards B in one direction, B travels opposite direction, therefore his velocity I have taken as negative. Due to their opposite direction of motion, they collide each other, they become entangled, becomes together, therefore their mass will become 115 kg. In which velocity they move? In which direction? Negative value will be getting it. Therefore, we say they move towards the left side. This is the conclusion we give. Total initial momentum becomes total final momentum, substitution and the simplification. Right now. Children, now we shall look into question and answer part which are there in the page number 126. The first question, children, if action is always equal to reaction, explain how a horse can pull a cart. See children, this is based on Newton's third law of motion. For every action, there is an equal but opposite reaction. See, the question is, if action is equal to reaction, how the horse pulls the cart, how the cart moves. If they are equal, they are supposed to be at rest, but it moves how? We shall see. See children, when the horse exerts force on the ground through its foot, the notes I will be giving you, children, the explanation I will be doing it now. The foot of the horse exerts force on the ground, we consider that as action, children. Horse exerts force on the ground through the foot. The feet of the horse pushes the ground with a force. We consider that as action. Therefore, in turn, ground exerts force on the foot of the horse, that becomes reaction. These two are equal but opposite. But the question is, how the cart moves? The answer is the force of reaction. Force of this reaction is greater than the friction force of the wheels of the cart. Remember, the friction force of the wheels of the cart. This is to be understood very carefully. Action is equal to reaction. They are supposed to be at rest, but still moves. Now, Because in this case, the force of reaction exerted by the ground on the foot of the horse, the force of reaction is greater than the friction force of the wheels of the cart. Therefore, it moves. Similarly, the firing of the rocket, the gas which is released from the rocket is action. Therefore, the rocket flies in the opposite direction. That becomes reaction. If they are equal, how they move? In this, the force of reaction is greater than the friction of the air of the atmosphere. Therefore, it flies. Likewise, children. The second question we have, explain why it is difficult for a fireman to hold a hose or a pipe which ejects large amount of water at a high velocity. See children, the firemen, when a fire accident takes place, they rush to the place, do the service. Okay. Large amount of water flows through the pipe with a greater velocity, therefore, which creates larger momentum. The flow of water produces larger momentum. Therefore, same amount of, because of third law of motion, same amount of momentum is produced in the pipe in the backward motion. Water flows in one direction with some momentum, therefore equal amount of momentum will be produced in the hose or the pipe and moves in the backward direction. Therefore, it is very difficult to hold. Therefore, the fireman holds the pipe with greater difficulty. The third question. From the rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the coil. See children, regarding this same kind of sum we have done already. It's about before collision and after collision. Directly we consider law of conservation of momentum. Before firing, mass of the bullet, mass of the gun. But before firing, remember, both the bullet and the gun will be at rest. Therefore, total initial momentum in this case, children, will be equal to 0 total momentum. Therefore, calculation of this. We have seen how to calculate this one. M1 V1 plus M2 V2 will be equal to 0. It is given in gram, children. We convert into kg. Mass 50 by 1000 kg into velocity becomes 35 plus mass becomes 4 kg into velocity is equal to 0. Now, the simplification part. 1 0 1 0, then this is 1 5, this is 20 times. These two will be divisible by again 5, 4 times, this is 7 times. Therefore, this will become 7 by 4 plus 4 V2 is equal to 0. Therefore, 4 V2 will be equal to minus of this 7 by 4 because of transpose, children. Now, this 4 has to move here, children. Therefore, V2 will be equal to minus 7 by 4 into 4 becomes 16. 4 into 4 becomes 16. 1 0 1 0, children. 1 5 is 20 times. 4 5 is 7 times. 7 by 4 is equal to 4V2. 4. Now the calculation part. V2 will be equal to minus. Slowly calculate this value, children. 7 by 16. Okay. 7 is divided by 60. This is bigger, children. Therefore, keep decimal point. Therefore, we get 70. How many times? 4 times. 64 comes. Therefore, 6 remains. Since we have already kept a decimal point, we can take one more 0. It's about 3 times, children. 48 comes. It's about 0.43 meter per second. Meter per second. Okay. This is about. Then the fourth sum, children, that also must be done with the same way, children. In the same way, two objects of masses 100 gram and 200 gram move along the same line in the direction of velocities 2 meter per second, 1 meter per second. Masses are given, velocities are given. They collide. After collision, they collide one another. The first object moves with the velocity of 1.67. Determine the velocity. The same way to be done, children. In this, mass and the velocity is given. Mass and velocity is given. They collide. Mass and velocity. Mass remains same. Velocity changes. The velocity of the first object is given. Velocity of the second object you can identify easily, children. So there we have completed all the example sums as well as the question answer part that comes in this lesson, children. This exercise part I will be sending you through WhatsApp, children. Please go through the text, children. Practice it. Thank you. Have a nice day.